What's up? We got Sir Sensation Black here. Nice. Come up, Sensation. Shut this music off. How's your day going, Sensation?
Oh no, not the music.
Not the music! Nick says he needs help today. That's good. I'm glad, dude. W help. I feel like people are like finally getting into like the school spirit. Well, you know what it is? People are finally realizing that, you know, they're screwed because they didn't learn anything. And now the exams are coming up. And they're like, I need help. This always happens.
Wait, when are US exams?
So final exams are probably in the next month and a half, but right now is usually where they give the midterms out. This or like the next week. I don't have the coin for firing my question in top priority. Yeah, you could do it. PUBG Lux. Yeah, I'm really screwed. Oh no, guys. Don't worry, I'm here. We can help you guys.
That's dope.
Me first. Oh, Nick did redeem me first. Yeah, good job, Nick. You actually understand how that works. What's up, Sensation? What were you saying, dog? And then Ethan, I'll get to you. One sec.
I love cutting across people, don't I? I don't mean to do it.
No, it's okay.
So our Scholastic year works from September until July.
Okay.
And so generally the final exams tend to be in sort of June.
June? Oh, because you guys have like a whole year. So yeah, we do semesters, so it's like 6 months. And like some schools like UCLA do like they do what is it? Quarter system is what they do as well. So quarters are like what is it? It's like every 3 months you have a class. Every 3 months you have final exams, which is like really fast. It's a 10-week class is what it is.
That's a little too quick for my taste.
It's a little bit too quick. All right, let's see. Yeah, we got a ton of questions. I got to go on a date later, so yeah, let's fucking get this shit rolling. All right, welcome everyone to Office Hours. My name is Dr. Gold, this is Actual Education, the stream that helps you out with math homework, science homework, all types of fun stuff. All right, let's see. Let's get Nick. Nick has a question. Wait, Nick, is it the same assignment you had like earlier, dog? What's going on, dog? You still doing this assignment?
That kind of looks like the same.
It's okay. He's asking a different question. He's asking for help with number 2. Gold, don't give Dark speaking power. It would be funny. I did give him speaking power. Isn't he up here? Is he not? I invited you, dog. I don't know. You got to hit it. There you go.
Oh, my bad.
Bob. Okay, cool. All right, number 2. Oh, bro, you know how to do this, dude. What is it? Monkey was helping you out with this one. Yeah, right. You should know how to do this one.
Wait, did he?
Well, it was a similar one where it was like a slope and an intercept. Okay.
Oh no! This one is different. Cause
okay.
I'm confused. It gave me the answer.
Okay, that's fine. All right. So how do you think you do this one?
I'm not sure what it's asking me to do.
It was asking to find the equation of a line. What's the equation of a line?
Is it y equals negative 4x plus 5?
Yes, that's all it is. Yeah.
That's the whole answer.
That's the whole answer, yeah, dude. Yeah, it's y is equal to mx plus b, right? Where this is the slope, and this is the y-intercept. Yeah. Do you get that?
Yeah.
Okay. Let me give you one that's like maybe a little harder.
I was just trying to make sure because I didn't.
You're all good.
Well, the y-intercept is 5. What is the y-intercept like?
Good. Okay, so the y-intercept. Let's go over this. So the y-intercept, because it's better for you to know conceptually what this is, right, than just like memorizing equations. Okay, if you have a line, right, the y-intercept is where it intersects the y-axis. Which one of these axes is the y-axis?
The up and down.
This one. Good. Yeah. So it's going to be right here. Okay.
Yeah.
What's special about here? Like what's the x coordinate here?
0.
0.
You
What's up, Grim?
My
Eh,
God, it's so loud. Holy
It's
shit.
yeah. Sorry, let me turn Grim down a little bit.
not loud.
No,
You're
you're
loud.
okay.
Bro
okay, Grim.
scared the hell out of my eardrums.
All right.
I'm literally whispering.
Oh, because for me, you're on 200.
Yeah, I had him
Why?
on 200 too, because probably your mic was ass earlier or something, dude.
Uh,
Bro,
Okay.
bro, let me tell you something real quick.
Okay, real quick.
Like yesterday,
Everyone wants to
I
say something.
built up my
but-
confidence. I saw this Hispanic girl. She
Yes.
had the smile of an angel.
Wow.
Hey,
Sorriso
And,
de un ángelo.
See, and then I told my brother to go back. I went up to her. I'm like, hey, I think you're
Ese.
cute. Like, can I get your Instagram?
Yo pienso que
I-
tú estás Karina. Y...
I got it.
Oh wow, dude. My boy Grim.
man.
My boy Grim, dude. He's rizzing up the street meat. Good job, dude.
Wait, bro, you said you have a date?
She's like 1 year above me. She's 18.
Oh, that's cool. Yeah, good for you, dude. Yeah.
Yeah.
Getting a girl's phone number is a good start, but I don't know. In Los Angeles, dude, just because I have a girl's phone number, there's like a 10% chance she like texts me back. It's like it's the worst.
No, she told me to text her, so and then I texted her and she answered, so
Wow, dude.
it's good.
Dude, a moment of applause for Grim here, dude. He managed to talk to a girl.
I
Okay.
need to talk to a girl. What's that supposed to mean?
Okay, nothing, dude. Okay, one sec. Can I let me finish Nick's question, and then we can
Okay.
talk about stuff. Okay. All right. So Nick, we have the equation line, right? Y is equal to mx plus b.
You text
Mhm.
Okay. When you put this in for like -4, right? That's the slope. Okay. So if I'm at the y-intercept, right? If I'm like right here, what do we know about our x-coordinate? What's our x-coordinate?
0.
X-coordinate is 0. Good. So you see how this thing would just become a big fat 0?
Yeah.
Okay, cool. So this goes away. And then what are you left with?
Y equals B.
Y equals b. Good. So this is why it's called the y-intercept, because it's the y value when x is equal to 0. And that's the same thing as b. So the y-intercept, Nick, right? It's all talking about this point, but it's talking about the y-coordinate for it, which is the same thing as when the x-coordinate is 0. So if you look at an equation y equals mx plus b, okay?
Mhm.
If the x-coordinate is 0, right? The y-coordinate is what? What's the y-coordinate? It's a letter. You got it,
I'm
Nick.
so lost.
You got okay. All right. Let's back it up. Back it up. Okay. We understand this is the y-coordinate on a graph, right? Sorry, the y-intercept,
Mhm.
right?
Mhm.
The y-intercept is where this line hits the y-axis. Okay, it's right here.
Mhm.
This has a y-coordinate, right? That's how far we go up this way, basically, right? And it
Mhm.
has an x-coordinate, right? That's where we are on this axis. Okay.
Mhm.
At the y-intercept, the x-coordinate is 0. But what you're always trying to determine is what this y-coordinate is for the y-intercept.
Mhm.
And that y-coordinate you can get from the equation of the line, okay? The equation of the line will always look something like this. Y is equal to mx plus b, if it's a
Yeah.
line, okay? If you substitute in x equals 0, right, then this whole thing goes away, right?
Mhm.
So the y-coordinate is then equal to
B.
b. So that's what the y-intercept is. That's why this plus b here, this is the y-intercept. Because it's the y value when x is equal to 0.
Mhm.
Do you see that? Yeah?
A little
Okay.
bit, yeah.
You believe me? you don't sound fucking convinced. Yes.
Because I what is the difference between the M and the X?
Good. Okay. The m is the slope, okay? That has to deal with how slanty the line is, okay? So when we have
Right.
y is equal to mx plus b, this is almost always going to be given to you as like some sort of number, right? They're either going to give you what the slope is, or they're going to give you 2 points and you have to figure out what the slope is. Do you know how to figure out the slope from 2 points?
Yeah.
Good. And whatever number you get, you're going to substitute into here, all right? So this thing is going to end up being some sort of number, okay? You're also going to need to put this as some sort of number, okay? That's going to be another number here. I'm going to put a different fucking color on it, right? Now what you have, and this is why it's the equation of a line, is because it tells you what the y is for every x. If I plug in something here for x, I get a y in return. And vice versa. I can plug in a y value, and it'll tell me what the x value is. So what this describes here, Nick, is it's describing all the series of x and y's that are on this line. If I give it an x, I can do some math shit, and then it'll give me what the y value is, right? Or I could tell it what the y is, right? I could put that in, and then I could do some algebra to solve for what the x is.
Cool.
But that's how that's why it's the equation of line. That's why it does stuff. Cool. Does that make more sense?
Okay.
Like, I want you to learn, like, conceptually, like, just learning, like, formulas and stuff, like, it doesn't do any good. You have to understand, like, why are we learning this stuff?
Yeah.
I know. Okay, good. I'm glad you're asking these questions, though. Bring me more in the future, okay?
Yeah. I got, soon I got,
What do
sine,
you got?
cosine, tangent.
Yeah,
All I know.
good. Bring me all the sine, cosine, tangent stuff. We'll do it up.
And I don't understand a single thing from it.
Okay, then, yeah, let me help you. Bring it. Bring it for next time. What's up,
Okay.
Hikaru? All right, cool. Nice, dude.
Alright, bye-bye.
Yo, what's good?
Thank
What's
you.
up, Hikaru?
How are you?
Good. Tired, busy, everything.
Yeah. Do
Feels
y'all ever, since you live in California,
correct.
do you get like a lot of earthquakes?
They happen sometimes, but I don't really feel them, honestly.
Yeah. I don't want to live in California when I'm older, because that's where all the famous people live.
Yeah, there's some. I mean, there are famous people who live in other places, but you're right. If you want to
And
be
the
like
YouTubers. It's the
a lot of the
YouTubers.
influencers do move out to Los Angeles just because it's kind of more of an entertainment capital, and it's easier to like connect with other people who are doing it as well. But you
like
can be
you.
sure, but I could do this shit anywhere. Like, and you can be an influencer anywhere. It just maybe
But how's,
helps.
like, the
if-
location of California.
Yeah, it helps probably if you're doing viral stuff at like viral type events and whatnot. It helps to be in like a city where viral things happen, which Los Angeles is definitely one. Yeah.
Have you met a famous like YouTuber or person?
I've met tons of famous people.
Like who?
I'm trying to think
Andrew
ones
Tate.
that no, I haven't met Andrew Tate. My roommate has had dinner with Andrew Tate. My
dear.
previous
Really?
roommate. Yeah.
What famous people have you met?
I'm trying to think ones that you know. That's the problem.
Tell me
Like,
any.
because I've met William Shatner. I've met Jamie Foxx. Like, I've met a lot of like.
You met
interesting-
Jamie Foxx?
Yeah, I met him at a taco stand once. He was
Like,
funny.
Wait, was that the game show host or the football player?
Who else have I met? It's just kind of like a weird one. I'm trying to think.
Have you met Brent Rivera?
Oh, you know what I've met? I've met the creator of Minecraft. Yeah, I've shook his hand before.
no,
Yeah,
you
no way.
haven't. That
Yeah,
is so
Notch.
bad.
Yeah, Notch. I've been at a party with Notch before. He's a cool guy.
Bro,
That's crazy.
There you go.
how? Are
you
you,
guys-
like famous?
And I know the other thing. And I've also partied with the creator of Rocket League. Yeah, there we go. That's the other one.
That is so
No
weird.
way, bro.
Yeah.
Yo,
People are like, yo, what? Yeah, I showed
It's
it on
'cause
another
you went to
stream.
UCLA.
No, I was in San Diego actually when I met the Rocket League inventor. And then I saw him again
Bro.
at Burning Man. I saw him at Burning Man. He had a big
Yeah?
art car, and I
Bro,
was like,
Burning
yo, it's
Man?
Dave. Yeah.
Yo, DJ Khaled was there.
I'm sure he was. Dark, you're muted. I come
Yeah,
back here
remember
and I
when
hear
people
Andrew
got
Tate.
stuck and Chris Rock picked him up.
Yeah, I saw that. Yeah, yeah. Notch is cool. He throws baller parties.
Bro, wait. It's
How
like
about
one
Tom
of those
Cruise? Does
secret
that count?
parties that
Tom
Arthur
Cruise. Have
has
you met
with
Tom
smart
Cruise?
people.
Sensation. You've met Tom Cruise?
Yeah, they were making a film up here recently.
Oh, that's fucking dope, dude. Oh, that's cool.
Bro, I want to be a Navy pilot when I'm older, so I'm like addicted to Top Gun.
That's cool. I don't think I've seen the new one. Okay, one sec.
Bro,
Let me
it's so good.
let me answer Ethan's question. I'll go to talking more things. Mason, what's your question? Mason, could you post this? No, give Ethan. Just give it a second. There's a lot of people here. Mason, can you post your screenshot in the help screenshots channel?
Hold
It's
on.
the easiest way for me to help you. Oh, you did. Okay, perfect. I'll do yours next. But let me do Ethan's real quick.
Hey, Dr. Gold,
What's up? What's up, Hikaru?
where do I post the problems?
In the help screenshots channel.
Okay.
There's a channel for it. Just post a picture
help?
of what you need help with. Help screenshots. Yeah, it's right. I'll show everyone on the Discord where it's at. It's right here. There's a big screenshot here. Yes, nice, Mason. This is perfect. Oh, chemistry homework. Yeah, fuck yeah. I'm gonna do yours next. Yeah.
Oh, what the
and
hell?
then I'll help Noise out with stuff. Okay. All right, let's go.
Wait, channel.
All right, give me some time.
Oh, I'm in
I'll get to.
Bloxy.
Yeah. Okay. All right. All right.
Help, I found it.
Ethan, what's up? What do you need help with both of these? Ethan?
I don't even know if I'm. Yes.
Yeah, it's good. All right, let's help you, dude. Yeah, dude, don't worry, dude, Ethan. The stream gets busy sometimes, but I don't forget about you.
You see, people can't please. Can't people can't shut up now.
No. But don't say shut up. It's okay. No. Everyone wants to talk. Everyone wants to talk. I get it, and
People
that's
are-
yeah. That's my job as a host is to kind of like maintain the chaos. So like it's okay. Just be patient. All right. Find the resultant vector of the following pairs of vectors by parallelogram. Oh, the parallelogram rule. Well, that's fun.
That ain't fun for me. That is not fun for me.
What's up?
That is not fun
Solve
for
that
me.
equation.
Hey, Car, I'm gonna push you down in the audience. People need. Okay. All right. What's up, Ethan?
Jesus, I really.
I know it's okay, Ethan. What's up?
Always, yeah. I don't know if that's really that fun because I'm really not getting it that much.
Okay. Well, then let me help you. Okay. So it says find the resultant vector.
Also,
Also what?
Dr. Go,
Yes.
the teacher wants it in like appropriate number of significant figures.
That's fine. We can do that. I can teach you sig figs. It's okay.
You know what that is?
Of course I know what sig figs are, dog.
Okay, man.
Okay. Here we go.
Six
Eight-
figs.
100 newtons and 80 newtons at an angle of this. Okay. So these are vectors. These are Noise's favorite thing.
Oh my goodness, of course.
Okay. All right. So we're gonna draw the first vector. Okay. You can always just draw the first one to the right if it's positive. Okay, because it says it's positive, right? So I'm gonna draw this one right here, right? And this is gonna be 100 newtons. Okay. Does that make sense so far?
Mhm.
Then I need another vector, which is 80 newtons. Okay.
Yeah.
But I need the angle between this one to be 150 degrees.
Mm-hmm.
So this is actually interesting. Okay. So, okay.
Also, I have a physics quiz that's gonna be based on this.
It's okay. We're going to go over it, dude. Okay. So here's what I like to
I'm
do.
really worried with it.
No, you're not. Don't worry. Don't be worried. So I like to kind of draw something like this. I like to draw like another coordinate plane here. Okay. I'm drawing like kind of like an imaginary one here. Okay. Yeah, tip to tail. Right. They don't need to use cardinal directions. It's okay. Okay. I need to draw something that's 150 degrees to this one. Okay. Do you know kind of where 150 degrees is? Ethan?
Sorry, I just muted myself because I feel like you're
Okay.
hearing something.
No, I don't hear anything. What's
Okay.
150 degrees from here? We're always gonna measure it to this angle, to this line here. Ethan's what we're gonna do.
Yeah. Basically, I'm thinking like 150 degrees is like almost like an obtuse angle thing.
It is an obtuse angle. Very good. So it's gonna go past here, okay, and it's gonna go like over here, right?
Okay.
Yeah, it goes backwards. Yeah, good job, Amog. Yeah, good. Yeah, exactly. This isn't really gonna make.
It's
This isn't.
obvious.
This isn't really gonna make a parallelogram.
It kind of looks like one to me so far.
No, because the results. Okay, so here's my issue with this. Your teacher probably screwed up, honestly, but it's all right. The issue here, okay, is that so Amog was right. Where it's called like tail to head, or what do you call it? Head to tail. Yeah, right. Yeah, I think they screwed up. It's okay. this vector here, Ethan, right? Do you see how it starts here and it ends here?
Mm-hmm.
The next vector, the green one, right, needs to start at the end of the first vector. That's why I connected it here. Does that make sense so far?
The end of the what?
The end of the first vector. So look,
Uh-huh.
here's what we say. This is like tail, right? This is the head. But then the head of the red vector is the same as the tail of the green vector, which then goes to the head. Okay.
Okay.
Tip to tail? Is that what
Mhm.
you guys call it? Tip to tail? I call it head to tail. Whatever. Okay. Then the resultant vector, Ethan, that's what connects the tail of the first vector to the head of the last vector. Okay? So that's
Oh
going to
my
be...
goodness, you're
that's...
just
that's-
making this way too confusing now.
No, it's okay. It's just going to be this one. This is the resultant.
Mhm.
Okay?
It's a full-on triangle here.
Yeah, this is where I think your teacher fucked up. Because I think what they meant to say was 30 degrees. I think they should have said 30 degrees on this one. Because do you see how this is not a parallelogram?
Mm-hmm.
Okay.
Maybe it was me who screwed it up.
No, I mean, isn't this what they typed out, or did you type this out?
I typed this out.
Oh, you typed it up.
I'm not
Well, it'd be hard for you to get that wrong. Okay. Let's pretend it's 30 degrees, Ethan. Okay? Because that's what I think it is.
But then that will. But this is an assignment. I need to get this right.
I know, but I don't... You can't use the parallelogram rule, I think, if it's if it's 150 degrees. I don't think you
I need
can.
to check something.
All right, check it real quick, because you can't use the parallelogram rule. The parallelogram rule, I think, only works with acute angles. Bum 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 bum. Yes, correct. Thanks, PUBG.
Mm-hmm. Well, it does say 150 degrees.
Okay. That's weird.
Hold on. They said that they will post it in the in my classroom.
150 degrees west of north? What do you mean, dude?
Yeah, it says 100 sorry. So it says here 100.0 newtons and 18.0 newtons at an angle of 150 degrees to each other.
Okay. Yeah, but that doesn't make a parallelogram. So it just straight up doesn't. Like this makes a triangle. It doesn't make a parallelogram.
Oh,
Okay. Let me do the second one, and then I think the second one will show you kind of, I think, a little bit more of like what's actually going on here.
alright.
Yeah, make a sketch of what I'm... Yeah, Amog, you show me. I don't think you can use parallel. I mean, unless I'm dumb here, but I don't think I'm dumb today. Okay. All right, let's say we do this one. All right? So this is going to go 6.5 in this direction, right? And then I draw like my little mini axis here, okay? And now I have to go 45 degrees, right? So that's going to be in this direction, okay? And that's going to be 8.5. Okay, this is 8.5 meters per second. Okay. The reason why this is now like a parallelogram, Ethan, is because the resultant vector, which I'm going to do with this purple one, is this. Okay? This is the resultant.
Alright.
Okay? Which
Also,
which kind of makes a parallel... I'll show you why this makes like a parallelogram. It's pretty cool why it does.
yeah, because I see how you made the parallelogram.
Yeah, you see how this makes a parallelogram? It's pretty cool, right? Look at that.
Yeah,
Parallelogram.
but see, I need to say one thing.
What do you want to say?
Thing is that we're gonna be using a geometry set like a compass, a protractor, and a ruler. That's what we'll be using in the quiz.
Yeah, okay. So we want, I could use a ruler if I wanted to, right? We could make this, what, 6.5 would be a little bit shorter, right? What would that be?
Oh, I also saw something weird today.
What'd you see? What'd you see was weird?
It was a different question where
The 6.5.
it's like, see, see that? You see what Amok has?
Yeah, but that's wrong. That's 30 degrees, dog. East of
Yeah, man.
north? What are you drawing there, Moog, dude? What? Excuse me? Yeah, no, but we said 150 degrees to each other, though. That's the key thing here, Moog. One second. Dude, fuck.
Honestly, this is way too confusing for me.
No, it's easy. It's just your teacher's writing things wrong. Yeah, this I don't know where he's getting this 150 degrees from. What? It would have to be east of north? 150 degrees? Like this amount? Is that what you're saying? The issue here, Moog, is like if this is your vector, right? This is the angle in between the two. This is the angle. Which, what you drew here, this is going to be 30 degrees. It's this new thing they implemented? What do you mean this new thing they implemented? What, did they just change math? I doubt they changed math. I didn't really pay attention in class. Yeah, okay. It's okay. Yeah, I don't think it's right. Yeah, if you didn't pay attention in class, so I can't tell you whether it's right or not. Okay, Ethan, if I had to like actually measure things with a ruler and a protractor, I'll show you how I would do it. Right? Okay. So I'm gonna measure out right what 6.5 would be. So that looks like it's right. I wish I could hold the ruler. I think it's here. There we go. This would be 6.5, right? I think that's 6.5. Yeah, that's about 6. Do you see how that's 6.5 centimeters, Ethan?
I see that.
Okay. No, I got 18 on 18. Yeah, okay. Well, show me what you did, Amog. Okay, so then let's do the other ones, like to scale, right? Because you wanted it to scale. So the other thing I would do is, then I would need to take a protractor, right, this, and I would have to see where 45 degrees is. Okay.
Wait, I want to ask something.
What?
This is not related to the topic, but what do people mean when they say their parents are going to trip them?
Their parents are going to trip them?
You're gonna die.
Yeah.
I've never heard that. That sounds like some Gen Z shit. Like what? They're going to trip them? What do you mean trip them?
Basically, the entire story is this. Today, our mid-semester report card has come today.
Good. Yeah,
And the
how'd you
thing
do?
is, you know how some people are, right?
Yeah, well, so yeah, some people don't do well in their classes. That's why they come to my stream.
Yeah, but the thing is that they say, I will not show my parents my grade.
Yeah, but the thing is, your parents will eventually see your grade. Like, you can't hide your grade from them
Yeah,
forever.
that's why I
Ethan, did you
say
say
it is
choke?
inevitable.
No, he said trip, dude. He said trip them. He said trip them.
Oh.
But yeah,
Choke,
I said
yeah.
I do.
But what's up? What's up, Ethan?
But this person, I said to them, it is inevitable, okay? Meaning that
Exactly.
no matter what they do,
Yeah.
they can't avoid it.
Yeah, you can't hide the truth forever, dude. Like, your parents are eventually going to see what your grades are. And so if your grades are bad, and this is another thing, man, like if you're doing bad in your grades, like hiding them doesn't make them better. It's better to admit that, like, hey, I fucked up, I need help, and then like your parents know like how to help you. If you don't tell your parents that you're doing badly, then they don't know how to help you. You know? Your parents just want to help you, you know. Delaying getting in trouble doesn't really do anything for you.
Literally, it's just gonna make it even worse.
Correct. Yeah, I'm glad you learned that lesson. That's a very important lesson. Okay, I'm trying to like rotate
I
this.
mean, I've learned it from a long time.
Yeah.
The ruler does not like you.
Dude, the ruler, I'm just trying to get the ruler. There we go. Ah, almost got it. Okay. There we go. Oh fuck. Okay, there we go.
All
right, Ethan, do you see-
Huh?
I'm measuring this as 8.5. Do you see I'm measuring this next one as 8.5?
Yeah, I can kind of see that.
You can kind of see that, right?
Don't move it.
Yeah, I can't fucking move it, dude. Dude, if I...
Don't breathe.
Fuck. All right, you know what?
Oh, no.
I'm just gonna say it's 8.5, dog. I'm just gonna say it's 8.5. Okay, Ethan, because I got a lot of questions we gotta get through, so let's do this one fast. See how this is 45 degrees? Do we see that, Ethan? Yeah, good. This thing is 45 degrees. Okay, good. And then I'm gonna measure, right, this thing as being 8.5 long, which I don't know. I can't really do it at this point. It's just hard. This thing, it doesn't have the best
long.
controls. Yeah,
Just have fun with that ruler all you want. You can't do it.
I really can't, dude. Okay, so I think it's like right here. There we go. I'm just gonna do this. It's like right there. Okay, cool. Okay, that's the next one. Okay, this is the 8.5. Okay, and then what you're gonna do here, Ethan, is you're gonna connect the base of this one to the top of this one. So you're just gonna do this. Okay, that's all you have to do. And then what this does, Ethan, is this kind of makes like a move this out of the way. This makes a parallelogram, right? No, wrong color. Do you see that, Ethan?
Always with the. Yeah.
Okay. So then what you're going to do to get the resultant, Ethan, is you're just going to measure what the length of this purple thing is. Which, I don't know. Let's get close. Let's get close. Dude, I'm so close. No! No, a little bit further. There we go. Oh, damn it. I'm like right on top of it. Okay. No. I swear I'm going to have a seizure. Okay. So it's like 14.1. Okay. So I think it's like 14.1. Okay.
Right.
If you wanted to actually calculate what this magnitude is, Ethan, you would want to like break these up into components is what you would do. Okay. So I would break up this blue one into like an X and a Y component. Okay. You know that this is 45 degrees, right?
This is really not what I'm used to, you know.
It's okay. You're going to learn it later. All right. Okay. So this is a triangle, right? This hypotenuse here is 8.5. So you can calculate this and this. Right? Do you remember how to do that? You remember how to do that with trig? This is why it's always important to never forget stuff like in math and shit.
Yeah, yep. I get it. This is actually trig.
Okay, so how do we do it?
Wait, where's that 8.5 up for the diagonal one, right?
That's the diagonal. That's this. That's 8.5.
Okay. I get it. So you gotta use Pythagoras' theorem. I'm pretty sure we only use tangent, right? Tangent, right?
No, you can use sine here, right? Right. Sine of 45 degrees is equal to whatever this one is. That's the opposite, right?
Mhm.
Over the hypotenuse, which is 8.5.
Mhm.
Right. So do you see how this side here is 8.5 sine of 45 degrees? And then this side right
I see
here
that.
is going to be 8.5 cosine of 45 degrees. It turns out that the cosine and sine of 45 degrees are the same number, so you don't really have to worry too much about that.
Cosine of what?
The cosine and
Cosine of
sine of the cosine of 45 degrees and the sine of 45 degrees are the same thing.
Okay.
So this gets you 6.01. This is going to be 6.01. Okay. So now if you want to figure out the length of this whole thing, right, we're going to add, because this one is only 6.5 in the x direction. So it's going to go 6.5 this way, 6.5 this way, right? So that's going to be 13 in the x direction, right? And then it's going to be 6.5 in the y direction, right? So now this is another triangle. Do you see how this is another triangle you can solve?
Bro, honestly, I'm really confused with this.
13 squared plus 6.5 squared is equal to c squared, which is this. So I'm going to do... well, it's not 13, sorry. Sorry, I did that wrong. It's 12.51. And then this is 6.01. I don't know why I'm saying 6.5. Wrong.
You're sounding I guess it's like way late or something.
No, it's not way late. No, it's early. I have a lot on my mind right now. Okay,
Okay,
it's
same
this
for me.
this squared plus 12.51 squared equals that, and then we're gonna square root it. And so I get the answer is 13.88 if I were to solve for what this is directly using the triangle method. Okay, good to see you, Nick. Which is
And then you-
close.
and then
It's
you-
close to the 14.1. It's close.
Alright. But you kind of wanted on the three significant figures, if that's the answer.
No, this one you want with two significant figures because you see how this only has two sig figs and this only has two sig figs?
Oh, okay, right.
So
And then you
technically,
just gotta round it off. to
so
14.
technically this is going to be 14 and this would also be 14. So now they would both be the same. And actually, I'm correct.
Oh. Just not so confident. I'm not so confident in the other one. That's for sure. No.
Yeah, because it's wrong.
I
Yeah,
literally
PUBG's like
see-
you'll do good on your date. No, I'm not worried about my date. I don't care about the date. Date's whatever.
Dr. Gold, literally, I'm looking at this thing and it's saying 100.0 newtons and 80.0 newtons at an angle of 150 to each other.
Yeah, it's okay. Your teacher's wrong. It's okay.
But what
all
if
good.
he doesn't care? What if he doesn't care?
If he doesn't care, then you just draw it how I drew it, dude. You draw 100 this way. And then you draw 80 this way, okay? And then you connect the two this way, okay? And then you measure this. My reason why I think this is wrong is because this is not a parallelogram. It's a triangle. But it's okay. All right. Let me help out. Who's next on my? Did I give you? Let me give you a bond coin real quick. One user Ethan. Good job, Ethan. Okay. More questions. What do we got? Falconer and Mason and yes. Wait, is Mason the same person as who else was asking me a question?
What?
PUBG. Are you the same as PUBG? Is Mason the same as PUBG? Or are they different people?
No,
Okay, cool. All right, Mason, you have your screenshot here, so I'm gonna help you out. Okay.
I think.
All right, let's do it. All right, let's clear the clipboard. You can see. 1 second, it's gonna load in real quick. Yeah, PUBG. What's your username on Discord? Let me know. Ooh, electronic structure of 4 atoms. This is cool. Which 2 atoms combine to form a covalent compound? Ooh, I kind of like this. I've actually never seen a question like this, Mason, but it's pretty cool. Do you understand what's kind of being
Yeah.
asked here? Do you understand what's
No.
going on here? Okay. So
Not really.
they're talking about the amount of electrons in every shell, okay? So let's look at
Alright.
atom W, for example, okay? W is a circle, right? That's the nucleus, right? And then what they're saying is I have, and I'm going to make the electrons red. And actually, do you see how there are 3 different numbers?
Yeah.
That means there are 3 shells, okay? Actually, let me make the shells in blue for you. Okay, so I'm going to do, sorry. I want circles. Yeah, 1, 2, 3. Okay. So when they say 281, Mason, they're saying that there's 2 electrons here. There's 8 in this one.
Oh, okay.
Okay, and then there's 1 in what's called the there's 1 valence electron. There's 1 electron in the outermost shell. Okay. Oh, you're
Yeah.
cosmic. Oh, yeah. Okay, I got you, PUBG. I'll help you. I'll help you right after this one. Okay, so this thing has 1 valence electron. Okay. So if I looked at, like, for instance, the periodic table, where in the periodic table would that thing be? Would it be on the left, in the middle, or on the right? It's okay if you don't know this, because this is something that's also kind of like, I want to say periodic table. Get this picture.
My advice to anyone is if you're doing physics, chemistry, etc.,
Yes.
buy your periodic table of elements and a
Yeah,
really
dude. I
big one
need
too.
I need to get it tattooed on like my forehead or something.
But the whole periodic table of elements on your forehead. Oh,
It's better. Do you see this chick that got like Kevin like tattooed on her forehead? I was like, what?
oh, Yeah, I've
Yeah,
seen
she tattooed her boyfriend's name on her forehead. I'm like, bro, you're gonna regret that. Okay.
it. No one has ever regretted a tattoo.
Yeah, right. Okay, so Mason, you see the periodic table here? Periodic table is pretty cool. It's like a map. All right.
Yeah.
Do you see how there are like different columns here and everything?
Yeah.
Okay.
The groups.
The groups. Good. Okay. So here's what happens. You see how there's so what happens is as I go over, this is what's called they call this technically I think they call it ionic charge, but it goes like this. +1. This is +2. And then everything over here is like sometimes +2, sometimes +3. It's really like you don't really know. It's kind of unknown. Then we get to the ones over here, okay? This is going to be +3. Then this one right here, or actually, sorry, let me move this color over a little bit, sorry. This is going to be +3. And then here is what we call is like plus or -4. Because then this is -3. Let me just draw all these things. One sec. This is -2. This is -1, and this is 0. Okay? This is called the ionic charge. All right? What's up, Tuhi? Okay. So, what happens is when I have things, when I have atoms that are bonding together and they're all on this side, do you know what type of bond they make?
Covalent bond.
Covalent. Good. Yes. Yeah, they share. So covalent, they share. When you have something from here and something from here, what type of bond does that make?
A giant. I forgot.
Ionic. Ionic. It's ionic.
Oh, yeah, ionic.
Okay, yeah. So what do I always say? So I say left with right, that's ionic. Right with right, that's covalent. Okay?
Mm.
So, when they're giving you the electron structure here, you're basically just determining whether it's on the left or whether it's on the right. And then you're seeing which with which does what. Okay, yeah. So, all you really care about here, Mason, is you just care about these numbers, the last numbers. These are called the valence electrons.
Yeah.
Okay?
Alright.
So, this atom W, right? Is that going to be on the left or the right? Which one is it?
Left.
Left, good. So this one's to the left, right? What about the 4?
Right. 4. I think right.
Right, good. Good. This one's gonna be on the right. And then okay, the 7 and the 8. All right, this is what I should have told you actually. Sorry. This is ionic charge, but also okay. I'm gonna put in a different color. Let me put it in blue here for you. Okay. The blue number here. This is the number of valence electrons. This is gonna be 1, 2. This is like 2, 3, or 4. And then this is gonna be 3, 4, 5, 6, 7, 8. Okay?
Okay.
So the 7, where's that gonna be?
The right.
Good. This one's on the right. Okay, and what about the 8?
The right too.
Good. 8 is also on the right. Okay, cool. Yes, it's over here. All right. Okay, so which ones are going to form covalent compounds? All right, so which ones do you think form covalent compounds?
Atom Y and Z.
So you need something from the left and something from the right. And actually, even more importantly, you usually want to have those things like add up to 8 is what you want them to do. Because 8 means that there's a full shell.
B.
Yes, good. Yeah, W and Y, right? Because W has 1, that means it's on the left. Y has 7, which means it's on the right. And even more so, the two of these things add up to 8, which is nice. Things with 8, like the Z thing here, 8 means it has a full shell. These are what are called the what are these things called? The noble gases. Because these things have full shells, they don't like to react with things. So they don't really form many bonds with stuff. So that's another kind of like little shortcut you can go through. Okay. All right. Electron structure is shown. Okay. X is this. Y is this. X and Y. Oh, wait. Sorry. I thought this was ionic for a second. No, this is wrong. Sorry. I do things wrong sometimes. Sorry. W and Y in this case, this would be ionic. Okay.
Oh, okay.
Covalent means you want two things from the right. Okay. Which I think this is going to end up being X and Y is what it is. Okay, so W is from the left, so you don't want that. And then X and Z, technically these are both on the right, but remember what I said about things with 8? They don't really like to share. They don't want to give. They already have a full set of electrons. They don't need any more electrons.
Yeah, exactly.
So it's called inert. They usually don't like react or bond with things. So this one's also wrong. So that's why it's X and Y. So this is the covalent, okay? And this is what I would say is the ionic one. All right?
Oh, okay.
Okay. Here's the structures. Okay. What do you know about something that has one electron on the left? That's actually interesting. How many valence electrons does this have?
Wait, 1.
1. Good. So 1 valence electron. How many valence electrons does this thing have?
5.
5, right? 1, 2, 3, 4, 5. Good. Okay. Okay. Cool. So we want to know these two things want to combine, but they want to combine in a ratio of a certain amount of things, right? And what you want to happen is you want this thing to have a total of 8 electrons in its outer shell. And this is a weird one. The first shell only ever wants 2. Everything else wants 8. If this had another ring around it, Mason, and we had 1 electron, technically this thing would want 8. But because it's the first shell, it only wants 2. Chemistry is full of exceptions, unfortunately. It makes things like complicated. Okay?
Yeah.
Okay. So, you have this Y thing, okay? And I'm just going to put out what the outermost shell... Well, okay, well, I'll draw all of them. But, yeah, here. The outermost shell is this. Okay? And then we have, right, electron, and then how many does this have? 5? 1, 2, 3, 4, 5, right?
Right.
And then we have one of these things, right? An X thing, okay? And it's going to also have just a single electron on it, okay? Now, what happens when things have a covalent bond? Do you know how that works? Like, what happens when things bond covalently?
I think they share electrons.
They share. Good. So what's going to happen is, let's say we just had a single X bonding with the Y here, right? Okay. They're going to share these, okay? So technically, how many electrons does the Y thing have now?
6? Wait,
6.
including
Yeah, because 1, 2, 3, 4, 5, 6, okay?
Yeah.
Cool. Is that the full 8?
No.
No. Okay. So we need a couple more of these X's to bond with it, right? So let's maybe put another one here.
Exactly.
Good. Okay. So this one's gonna bond, right? And they're gonna share. Okay. Now the Y has 7. So we need another one, right?
Yeah, 1 more.
Okay. And now the Y is happy, right? Because it has 8 electrons
Alright.
in its outermost shell. And the other thing that makes all the X things happy is each X has 2 electrons in its outermost shell. Do you see that?
Alright.
Yeah.
I think, like...
So what would the name of this compound be? Yeah, Cosmic's got it right.
Wait. Is it ionic or covalent?
So it's covalent. No, this one's covalent. We already said it's covalent. But here they want to say what's the formula. You see this question down here, Mason?
Oh, yeah.
How many X's do you have?
You got 3. Oh, it's D.
Good, D. Yes, X3Y. Okay. In the following diagrams, X and Y are different elements, which shows the arrangement of the outer electrons in a molecule of methane. Okay. Do you know what methane is?
Yeah.
What is it?
It's like a gas.
It's a gas, but the formula for it is CH4. I think that's methane. Yeah, CH4. Okay. How many electrons does carbon have? You gotta kind of like look here. Do you see where carbon's over here?
It's kind of blurry. I can't really see it.
Carbon's right here, right?
12.
It has 4, right? Because remember, this down here, this is the number of valence electrons. It goes like 1, 2, don't worry about this. And then 3, 4, 5, 6, 7, 8. Good. Yeah, good. Yeah, cosmic. Yeah, 4. So carbon has 4 valence electrons, all right? So if I wanted to draw, right, in terms of X's and Y's, right? That means there's an X thing here, right? And it's got 4, they're denoting the X electrons as X's, which is cool. All right, whatever. It has 4 electrons in its shell, right? It's got 4 valence electrons here. Okay?
Okay.
And then H4, okay, means, and they're calling this thing Y, and they're calling this thing X, for instance. That means I have a Y here, right? A Y here, a Y here, and a Y here. Okay? I have 4 hydrogens connecting to it. Hydrogens only have 1 valence electron on them. Okay?
Okay.
And what's going to happen is those 4 hydrogens are going to share their electrons like this. So now each hydrogen has 2. And the central carbon, which is the X, that has 8. You see how it's 1, 2, 3, 4, 5, 6, 7, 8?
Yeah.
Okay.
So it'd be D.
I think it would be D. Yes, good. As well. Good. Yep. Okay. Which compounds are pairs of electrons shared between atoms? In which compound are pairs of electrons shared between atoms? So this shared, right? Shared means covalent, right?
Yeah.
CH4, is that covalent? Yeah, I guess so. Yeah. Hydrogen's weird, Mason. Hydrogen, like, sometimes plays here, or then it sometimes, like, plays here. It doesn't matter. It's kind of weird. So, yeah, I think methane is, too. Lead bromide, that's a weird one. So, lead is... where the fuck is lead? Lead is PB. Where's PB? Oh, lead is here. Lead bromide.
Wait.
Yeah, it gets
Here's
weird
the
when...
better question. What's it for?
Yeah, what is... Yeah. Lead bromide... I want to say that's ionic. And then sodium chloride. Sodium's here. Chlorine's here. This is definitely ionic. So this one is not going to be sharing electrons. So I think it's 1 only. I think that's the only covalent one. You eliminate A and B. You
Yeah.
use C and D. I think, yeah. Well, which one, Cosmic, are you talking about? Cosmic, are you talking about this recent question? I think lead bromide is ionic. This is... is. Yeah. Yeah. It's ionic. It is ionic. Okay, good. Okay. Exactly, good. Yes, I agree, cosmic, yeah. This is the only covalent thing, because it shares the electrons. And then which statement about bonding is not correct? Carbon can cause 4... Yeah, I mean, this is true, right? That's what happened with methane, right? Chlorine atoms react to gain a noble gas... maybe? Chlorine has 7 electrons, so it only needs one other thing to have 8, which would be nice. Covalent bonding involves losing and gaining electrons. Aha! This is wrong. Losing and gaining electrons is ionic. That's what ionic is. Okay. And then this is also true. So these are what are called the diatomic atoms. Yeah, covalent shares. It doesn't lose or gain, right? But this is another cool thing. Yeah, what's up?
Is it mnemonic? I don't know.
Mnemonic. Yeah, it's called Brinkelhoff.
Yeah, mnemonic.
So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. All of those, when they're in their states by themselves, are diatomic, which means like fluorine doesn't like to hang out by itself. It's always F2, or chlorine doesn't hang out by itself. It's always Cl2. If they're just by themselves, you can still have a single chlorine in, for instance, NaCl. Which, little bonus question. What is NaCl? Do you know what NaCl is, Mason?
So it's
something you put on your fries. I put on my fries all the time.
that's sodium.
Salt. Sodium chloride is salt. Yeah, this is sodium chloride. This is sodium.
Yeah.
Yeah, good job. Chloride. And because it's something from here and it's something from here, is that ionic or covalent? Remember what? Remember it's ionic. Good job, Mason. Great.
Yeah.
That was fun.
Yeah.
Did it help you out, Mason?
Yeah, thank you very much.
Okay, you're very welcome, dude. Yeah, anytime you got questions in chemistry and stuff, dude, I got you. Like, nobody asks chemistry questions here, and like, I like teaching chemistry. Chemistry's fun.
The only chemistry book I've got is Chemistry for Dummies.
Chemistry for dummies, he says. All right, let me see. Cosmic.
Listen, I'll start speaking normally, and then you won't be able to.
No, I like the accent. You give us some like some flair, dude. There's a spice of life to this, which I like. It's good.
I try my best to speak with an English accent, so it's clear for everybody involved.
What's the other accent? Do you have a Cockney accent?
No, I'm from Scotland.
Yeah. Oh, that's right, from Scotland. Yes, I keep forgetting. I know you're from like north part of England, but like so far north it's Scotland.
I live in north of England. But,
north of England.
I'm Scottish. My parents are Scottish. Their parents are Scottish, and so on and so on.
There you go. The Scots.
So I speak like this most of the time.
I speak with the team. What's up, Teacup?
Hello.
Hello. Let me help Cosmic. I haven't helped Cosmic in a while. Moment of inertia. Ooh. Ooh. We're getting a little complicated today. Yeah. Is this an engineering class that you're in, Cosmic? I feel like it is. Okay.
I can't even read the diagram.
Yeah, it's yeah. Dr. Claudia Ron, like, dude, why did is this your teacher? Is your teacher like this much of an ego trip that she needs to like put her name in the questions? Okay. Makes a simple wood vase by turning a wood cylinder on her lathe. The vase has the dimensions as shown. The density of the exotic wood is that. Cool. Determine the following quantities. Okay, good. You got the mass right. That's good. I'm glad you can do this. That's someone's friend. Okay, that's okay. Moment of inertia around the vertical axis. So that means around this axis, right? There's a hard way to do this and an easy way to do this. The hard way would be to use integrals. The easy way would be to look it up on a table. Let me look up moment of inertia table. Because it's a hollow, but it's not a thin ring. This is the cool thing. It's not thin. It's not a thin ring. Oh, you don't know how to do it? Okay, no, it's cool. You just got to look it up. I mean, they got to give you the table. Okay, this is it. Okay, so you just got to look up like what shape and what axis you're going through here, Cosmic. So in this case, right, we're looking at a hollow cylinder, which is this, right? And the difference between a hoop and a cylinder is a hoop is assumed to be really, really thin. But this thing has like an inner radius and an outer radius, okay? And so they say this is the answer. So the moment of inertia, I, is equal to m over 2. You already calculated m, right? So, and I think you want this in kilograms. So we're gonna say this is 0.8619. Okay. Over 2. And then that's r inner squared plus r outer squared, which your wait a minute. What do you mean? Wait, there's a bottom as well? Excuse me? Oh, it doesn't go all the way through. Oh, Jesus, what? What? Why did your teacher do this?
It did say vase.
Fuck. It has a base?
Well, because you said it's a vase, so.
It's a vase. Okay. All right, whatever. It's not the worst. It's not the worst. Okay. Here's what I'm going to do. Yeah. This is, okay. I'm going to break this up into 2 separate things. Okay? So, I'm going to break this up into the upper part of the vase, right? So, wished. Yeah, let's do this. Hopefully my picture looks a little bit nicer than your teacher's, you know? I don't know, I'm trying here. Oh, Jesus, no. Go. Move. Ah, you motherfucker. Okay, there you go. All right, whatever. Okay. Yes, looks very nice. So I'm going to do the moment of inertia here. Which this one is 1/2. And it's going to be m. And then it's going to be r1 squared plus r2 squared. Right? I'm just going to copy this over. I just need this information. And then... okay. And then what I'm also going to do here, Cosmic, so that was just this part of the vase, if that makes sense. And then I'm going to do the solid part as well. So we're going to have the moment of inertia of this part, right? And then we're going to add it to the moment of inertia of the solid part at the bottom. Yeah, which is just going to be this. So, all that. Okay? And these have different formulas, okay? This one... For a solid cylinder, where did I put it? Not here. Excuse me. Okay, there you go. That is... That's going to be this one right here. Do you see how this is the axis of rotation? So we're rotating this way. And that's just equal to mr squared over 2. Cool. Okay. Okay, cool. All right. And then the key thing here is that, so what's the density of this thing? Density is, oh man, 700 kilograms per meter cubed. Okay. So then mass is always going to equal to the density times the volume, which in this case is 700 times whatever the volume is. All right. And so let's get some dimensions for this. So this is 23 millimeters by, the diameter is 104, so the radius is 52. So this right here, we're going to have R is equal to 0.052. And then it's 23 millimeters thick. So then this right here is going to be 0.023. Okay. So the volume of this thing, right, is going to be pi times the 0.052, which is the radius, squared, times the height, which is 0.023. Cool? So that's the volume of this thing. Okay, great. Okay, cool. What'd you get what'd you get for the volume of this one? Let's just save some time. What'd you get for the volume of this one? This is going to be pi, and then it's... Oh. Total volume of what? Of the whole thing? Because the problem is, like, there's a volume of this, and then there's a volume of this. These are two different things, right? So, you know, we can pull out trusty dusty calculator, right? Let's just see. I just want to double check your numbers. Times 0.052 squared, good, times 0.023. So that I get 1.95 times 10 to the minus 4. Okay. And then this one, let's see, R outer is 52, and then it's why 15 millimeters, dude? What? I gotta use half numbers now. So R inner is equal to 52 minus 7.5. You get that? That's what the inner radius is. So that's what is that? That's 40. Fuck. It's 44. 44.5. Yeah. So this is 44.5. Okay. So this volume is equal to pi. R outer is going to be 0.052 squared minus 0.0445 squared. Good? Good so far? Okay. So pi times 0.052 squared minus 0.0445 squared. This is where I'm just like, engineering, dude, is such bullshit. This is all just fucking busy work. Like, are we really learning something here? I'm just learning how to, like, put things in a calculator. I mean, there is some learning with figuring out what the volume is, but it's just annoying that you have to do all the numbers. Okay. So this is, what is this, 0.0227? 0.00227 meters cubed. Right? I rage quit last night. Yeah. Especially if, like, you're not getting the right answer. You're just like, fuck this. Yeah, no, I get you, dude. 100%. Okay. Because honestly, I would just... Okay, if this was a physics class, by the way, Cosmic, they would just want everything in terms of variables, and I could do this in, you know, probably 2-3 minutes. But the fact that they make you calculate all the numbers, that's just what takes time. Yeah. It's so annoying. Like, fuck. Okay. But here, we'll make sure we get an answer for you. Okay. So mass, right, is always whatever the density was times these different volumes, okay? So that's going to be 1/2 times 700 times 0.00227, right? And then it's times 0.052 squared plus 0.0445 squared, right? And then this one is going to equal to 700 times 1.95 times 10 to the minus 4th squared all over 2. Okay? Yeah, it is. All right. Let's see if we get the right answer here. So, okay. So 0.5 times 700 times this number times 0.052 squared plus 0.0445 squared. Cool. That gets me 0.0037. And then when we do this one, so that's 700 divided by 2 times whatever this radius is. What was this radius? Is 1.951 we had? Yeah. Times this lovely creature. Blah, 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 blah. To the second. That gets me 1.34, 1.336. I know, Jesus. Yeah, I know, this sucks. It's okay. Oh, wait, times 10 to the minus 5. I'm fucking wrong. Sorry, dude. Okay. Not much inertia in that last thing. It's okay. So we're going to add that to this one to get, all right, and how many sig figs they want? Probably, dude, it looks like 3 sig figs. They want 4? I only see 3 sig figs on this question. But okay. Okay. To 4 sig figs, that's going to be 3.741 times 10 to the minus 3. I believe that's what that's going to be. What did you get for your answer? I'm curious. What was your first attempt answer? Are we at least in the ballpark? Units, units should be kilogram meter squared. That's what it should be, I think, right? Kilogram times meter squared. I believe that's what it is. I think it's the units for. Are there other units? 10 to the 12. Ha! No. 10 to the 12 is huge. Bro, what? That's like that's more than a billion, dude. That's like a billion. Oh, man. Yeah, no, don't do it.
That's a rather large vase.
That's a big fucking vase, dude. 10 to the 12? Is this answer right? Just let me know. I'm curious.
I want you in your engineering class to make a vase. Or a giant redwood tree.
Yeah. Let me see if Falcon's still here, and then I also got to do teacups. Ugh. I wanted to go running today. I do like to run. What else did we have? I didn't miss anyone else though, right? Oh, then Hikaru's here. Dude, chill. Did you see what? Oh, it's not right? It's not right? Oh, motherfucker, dude. Okay.
Wait, what?
Dude, Hikaru, dude, look at the question Hikaru posted for me, dude. Wait one second. Clear my clipboard. It's not this one.
Too many buttons to press.
This is what Hikaru posted. This is a very famous math question. This is like, I don't think this has ever been solved, or like it's been proven that it's not.
I've seen that before.
Yeah, no. But you can't. I don't think you can do it for cubes. Oh wait. Sorry, I'm thinking. Well, actually, no. I don't think this works. Yeah, I think this is a trick question. Cosmic says the question's wrong. Oh, that's a shame. Let me make sure we didn't do anything stupid. I don't think we did anything stupid. Pi r squared times h, right? And did I do that right? Yeah, it's 52. Let me just make sure I'm just not losing myself. And then here, I'll do yours, Falcon, dude. 52 minus 7.5. 44.5. Yeah, I should be right there, dude. I should be right. Oh, you know where we fucked up? Oh, my bad, PUBG. I forgot to put in the height here. Forgot the height. Volume is pi r squared times the height. One sec. One sec. Bruh.
No
Lol.
longer a vase. It's just a puddle.
Yeah, it's just a puddle. Yeah, okay. So 1 sec. Yeah, no. I make mistakes sometimes. So that height there is going to be the 270 minus the 23. Damn, that's a bitch. All right. Minus the 23. Which is going to be 247. So I forgot to multiply this by 0.247. My bad. No. Sometimes I'm wrong. Okay. All right, so where did I do that one, though? Where was that math? Okay, that was this. Okay, so I have to do this times 0.247. Okay, so that gets me a different answer. So that makes this 5.616 times 10 to the minus 4. Which is going to change this number, right? It's okay. We just got to change this. So where was it? This one. So this, I need to also multiply this by 0.247. So that becomes 9.21. And then it's okay, because then I can take this number and I can still add it to my original 1.366. This is why it's handy to have the calculator answers just here, because I don't retype shit again. Okay, there we go. Okay, now the final answer to 4 sig figs should be 9.341. Yeah. Things slip my mind sometimes, dude. Tell me if that's right. Is it right? Wrong, sir! That's dope. Not dope. What else did I screw up? I don't think I screwed anything up here. Pi r squared minus r squared. Mm-hmm. Mm-hmm. Yeah, and I think they just add. I'm pretty sure they do. MR squared over 2. Oh! Bro, wow. I'm really screwing up. Sorry. This is rho. This is v. Together, that's m. I forgot to multiply by r squared. Jesus. Okay. We're getting closer. We're getting closer. This is the problem, dude. If I had all these things in fucking variables, I wouldn't be making these mistakes. But it's when I have to transcribe all the numbers over and over again, like, it's just fucking annoying. Jesus. Ugh. I want to say bad things about your teacher, but I'm not going to. This is also why I didn't get into engineering. I was just like, this is just busy work. Okay, 1 sec. Okay, we're gonna get this right. I am a persistent man. I do not take no for an answer. Well, but you know, okay. Okay, good. Times 0.5. Okay. There we go. Okay, this is 1.849 times 10 to the minus 4. Yeah, it's good. It's good. It's good, dude. Okay, and then we're going to do this. I should have known, because that moment of inertia did look really low, honestly. Okay, there we go. Okay. So, final answer, I think, is 1.106 times 10 to the minus 3. And then that should be kilogram meter squared. How many attempts do we get at this thing? No. It says no as well. Unlimited until I get 0%. All right, one sec. I'll take one more gander at this just to make sure I didn't do something stupid. I'm pretty sure I didn't. Well, then we found two things stupid I did, right? Let's make sure that that's right. 700 kilograms. Okay. Uh-huh. B is pi r squared. Mm-hmm. Pi r squared times the height. Good. Which that's the 1.95 times 10 to the 4. And we did that times the 700, right? And then we multiplied that by .052, right? Yeah. Okay. Then times 0.5. Yeah, that was okay. I like that. That's okay. 1.849 times 10 to the minus 4. Good. Okay, then this moment of inertia, I just want to make sure this was right. So V is equal to... Or you know I can double check this actually here. Let me see if I can actually get the right mass, right? So if I take my... This will tell me real quick whether something's wrong. If I take this volume, right, plus the 1.95 times 10 to the minus 4 we had. Where'd it go? Okay. I get that. And if I multiply that by 700. Aha. I get 530 grams. Which is already not what you got, right? You got 860 grams. Correct? Right? Like that we got this. This was the correct answer. Yeah, so something's wrong with my something's wrong with my volumes then. Uh-huh. Yeah, pi times. So the volume of this, I just want to make sure. I don't know. I always got to make sure I'm like okay here. Pi times 0.052 squared, right? That's the whole radius of that, pi r squared, times 0.023. That's a volume, right? Plus, and then it's pi r outer, which is 0.052 squared, minus r inner, which is 0.0445, right? 7.5 squared, good. And then times the height, which is 270 minus the 23, which is 0.246, right? Okay. Let's just see what we get from that. So, I'll multiply all the pi's out eventually. So I do 0.052 squared times 0.023 plus okay, so the plus 0.052 squared minus 0.0445 squared times 0.246, all of that times pi times 700. Oh, sorry, I wasn't showing my calculator. Yeah, we get different we get different masses. Okay. So something's wrong. So either this diagram is being first of all, how did you get this? Did you actually do this, Cosmic, or did you just look this up? Yeah, show me your work. Yeah, can you send it? Let me see it. I want to see it. He's like, yes, I did it. I'm glad you did it. That's good. Yeah, send it in whatever. Because maybe I'm just like not understanding how she's making this lathe or this vase. It's apparently not a very simple wood base. Cool, thank you. You got good handwriting here, Cosmic. Good shit, dude. Yeah, I got you. All right, let's see what happened. Okay, so you found the volume of the whole thing. Wait. Volume of the whole thing. And then you subtracted it from... Okay, first of all, yeah, I'm screwing up with the 246. First off, this should have been 247. I can't do basic math today. Uh-huh. Okay, I see. You did the whole thing. Then you did 247. Okay, the .037. Where's that coming from, though? Wait. Sorry, where's my calculator? 102, right? Or 104. Divided by 2 equals that. Minus 15 divided by 2, right? Should be 44.5. Yeah. Where are you getting this from? Where's the .037 coming from? No 104 divided by 2? Why not? Oh, you're so right, dude. Sorry. No. Yeah, no. Yeah, I screwed this up. Okay. This is 52 minus 15. Yeah, this is 37. Okay. I see the error in my ways. I'm making some really dumb mistakes here. I'm sorry. It happens. Yeah. It's 37. Okay, cool. Okay, let's go back to this clusterfuck of fun. Okay. No, I see exactly where my errors are. This needs to be .037. Again, it comes down to me just reading the numbers off. Like, the way we're doing the question is right. It's reading all the numbers is a pain in the ass. And then that's .247, right? Okay. I think I got it now. Yeah. This should be .037. Okay. Let's do it. Okay, let's get the volume of the first one, right? So that's going to be pi times .052 squared minus .037 squared times .247. That's our first volume. And so then I'm going to do... Oh, that's our first volume, right? So I'm going to multiply that by 700. And, to get the mass, right? Good. And then I'm going to do times 0.5 times, and then it's 0.052 squared plus 0.037 squared. Okay. Good. So that's my first inertia. So we're going to say like I1 is equal to 0.01477, whatever. Okay. Okay. Next volume. I think our volume here was okay. So this was, I think all our calculations here are actually okay. This is okay. This was the 1.849 times 10 to the minus 4, right? Pi, yeah, r squared. Okay, so this one was okay. So we're going to add this one to 1.849 one we had. Okay. Let's see if we get this one. Oh, okay, so this is 1.662. .662. Okay. Is that correct, Cosmic? I'm glad we could double check on the volume at least. Yeah, you were right with that. I'm at the hour and a half mark. Kilograms meter squared. Yes, correct. Run it. Dude, the fucking anticipation, dude. You're killing me, dude. Killing me with this anticipation. Yes, it's correct. Woo! Yes, Falconer, thank you for staying with us on this one, dude. Holy shit. Okay.
Hey, Dr. Gold, I'm back.
Yeah, one sec. I still gotta do Falconer's question.
Okay.
Oh my god, my head, dude. Yeah, crazy as fuck. Yeah. Okay. So, well, okay. The important thing that I want you to know is again how to read this table here. Not this table. Where's the fuck that table go? This. Yeah. This is the important thing. Cosmic. This was the important part of the lesson, knowing how to read this. And then all like the garbage that we had to do here, this is just mass times volume. And the reason why this gave me so much trouble is because this diagram is just like really complex, and the numbers that are given aren't really intuitive. Like, really, I want R1, I want R2, I want this height, I want this height. But they gave me, like, the total height, and then they gave me, like, the total width, and then the thickness, which, yes, I get it in the engineering standpoint. That's what you give on a diagram. But in terms of the physics of doing the calculations, there's so many ways to make a small little mistake. Like, I was dividing this by 2 because I was thinking it was the whole thickness or something, like, I don't know. Your work did help. Well, it helped me double check that why I was wrong. Nice job, Falcon. Okay, yeah, great job there, Cosmic. He's like, but you have like 3 other questions. But I hope that one at least help. That. Let me see what the other ones are real quick before I do Falcons. I just want to see the flavor. Wow, pendulums. Yeah, that sucks. Okay. This is not too hard. You should know this. You haven't tried. Yeah. 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 Try doing the other ones. And let me know. Yeah, because I think you didn't. I don't think you attempted these ones yet, right? Yeah. Attempt the. When is all this due for you, Cosmic? When is it due? Nightbot's like, how about no, dude? Oh, you rage quit? Okay. Well, when is it due? Because maybe I can help you on Friday. End of the week? Okay, so can we go over these on Friday? Can I go over the other ones on Friday? Is it due at like the end of Friday? Cool. All right, good. Yeah. Come by the stream on Friday, Cosmic. I'll help you out with them. Cool. All right. Where is Falconer's question? Falconer. Dude, where did I put your question, dog? I swear I just had it. No. That one sucks. No. Okay, whatever. I'll find it again. Okay. Okay, here we go. USDA. Oh, this is cool. This is actually kind of applied to farming stuff. Well, you're not really doing farming stuff. You're doing like nature things, right? Uses sample surveys to produce economic blah blah blah. Okay, it's good. Random independent samples. That's great. The prices producers use in those 2 months of summary is the dollars per bushel as below. Good. Okay, sample size, sample mean. Assume the normality and construct a 95 confidence interval to determine if there is a difference. This is cool. So this is a 2 sample confidence interval. Yes, good. Yeah. So X bar is going to be the difference. So it's really like X1 bar minus X2 bar is what it is. You want to see if the difference is 0 or if it's not 0. That's what you're testing for. So null hypothesis, right, is that X1 bar minus X2 bar is equal to 0. And then the alternative hypothesis is that X1 bar minus X2 bar is not equal to 0. Yeah, good. So some assumptions, SRS, normal, dist, I don't know, n is greater than 25 or something. That's usually a good one. Cool. Okay. So, reliability coefficient, they want to be 95% confident, right? So that's alpha is equal to 0.05. I think that's what we call the reliability coefficient. That's what we call it, Falcon, right? Is that what you guys call alpha? Alpha's like the percent chance that it sucks. that like you did something wrong. Or yeah. There's a 5% chance that like we're wrong. Yeah, exactly. Okay, cool. All right. So this is where, I don't memorize everything off the top of my head. 2 sample confidence interval. There you go. What's the formula? There we go. That's what I want. Yes. No. And yeah, and this changes whether they're independent samples, and I think they are independent samples, right? Yeah, good. Random and independent, yeah. Because if they're paired, that changes. Oh, God, Jesus. No. Okay, this is what I want. I want this equation. Okay.
Yeah,
What's up, Ethan?
I wanted to say something.
What do you want to say?
I sent the link to my report card, my Mr. Messer report
Oh,
card.
nice, dude. I'll check it out. That means I get to send you an Xbox controller?
Obviously, what else?
Oh, yeah, dude. Sick! Yeah, I'll check it after the stream if I have some time. But then, yes, I'll get that to you. Oh, and you're going to go to the US for Christmas. That's great.
Yeah.
Nice.
So, okay.
Yeah. Let me see. Okay. So Falcon here. These are the meat. This is what we're estimating, right? And then this is the difference in the means. So this is going to be 3.61 minus 2.95, right? Plus or minus, and then TS is the T is the I forget what they call this, but it's like a z-value, but it depends on the number of samples you have. So we have to go figure that out because I forget if you pool the variances or not. Okay. We have to look at what's called the degrees of freedom. Okay, so it's N1 plus N2 minus 2. That's what they say here. Yeah, it's always you're either like adding the ends and like subtracting 1 or subtracting 2. So in this case, the degrees of freedom is n1 plus n2 minus 2, which is going to be these two numbers added up. So that's going to be 135 minus 2. So that's going to be equal to 133. Okay? So if I go look up my t-table for that, where's my t-table? There it is. N is greater than 30. We use what's greater than? Well, the total N, yeah, is much greater than 30. So you're just going to use it for 100, I think, is what we're going to use. You see how there's a value here for 100? And then 1,000. Yeah, and then basically, and if you go to the infinite level, T basically becomes Z. So we don't really care. But so it's 2 tails with 5%, which means that there's 0.025 and 1 tail. So 0.05, we're going to go down this table right here, okay? And we come down to 100, and so that's 1.984, okay? So 1.984, and then it's this, which is the standard error, which looks like, yeah, this is pooled variances. So in this case, we say Sx is equal to the square root, and this is S1 squared over N1 plus S2 squared over N2. Variance is standard deviation squared, is that right? Yeah, standard deviation squared is variance. Okay, cool. Yeah, you can post a flowchart. Yeah, you want to send it? So this is going to be 0.036 over 45. And this is going to be 0.048 over 90. Yeah, post it. You're good. So 0.036 divided by 45 plus 0.048 divided by 90. We square root those two numbers. And we get standard error is 0.0365. Okay, cool. So now this is going to come right here, right? And we're just going to calculate it, right? So we're going to say, what is this? 3.61 minus 2.95, right? 0.66. And we're going to add that to 1.984 times our standard error. So that's going to be 0.732. And then we're going to subtract that. From our number. Okay. Which gets me 0.588. Okay. So my confidence interval then is 0.588 comma 0.732. Let me see. Did you post something for me yet, Falconer? I'll give him a second. It's an office hours? Okay, cool. Let me check it. Aha! Okay, good. Yeah. This is exactly, yeah. Great. Yes, good. Okay, so they were independently sampled. Do we know that? Yes. So this is what we used, right? And they use the Z distribution. Okay. Well, okay. Sigma here, though. So Sigma here, Falconer. This is if I know the population mean, which I don't. Or the population standard deviation. I don't. I know the sample standard deviation. So this is the population. And then this is the sample standard deviation. Okay. And I mean how this works, right, is you have a big population, right, which is like all the things. But what you end up taking usually is just a small like sample of that population. So for instance, you know, these 45 samples is not all of the producers, right? It's a sample of the producers. So this standard deviation is a sample standard deviation. So actually I don't know sigma 1 and sigma 2. That would be if I surveyed all of the producers in the United States, which would take a long time. So yeah, we don't want to use this one. We did estimate this. They were both over 30. So we ended up using this. Yeah, which we kind of basically did, Falconer, because I used the T I did this. I used the TN1 plus N minus 2. I did the N1 plus N2 minus 2 as degrees of freedom. That's what we did right here. And that ended up being a big number, and we used the same equation for standard error, but I used a T distribution. But if you use a T distribution with enough samples, it's basically the same thing as a Z distribution, if that makes sense. This is where, like, yeah, statistics has a little bit of wiggle room into, like, what you want to, like, what's the exact equation, what's the exact way to do it. And this is why I used to get really mad if I helped students with homework and it was graded online, because as you saw previously, right, with Cosmic, their homework has to be exactly right with like the right decimal. It has to be like exactly right. And in statistics, like some of this stuff is kind of up to interpretation, like which one you want to use. Like this is kind of arbitrary and is greater than 30. It's kind of like, it's like, okay, like you can, but is 30 enough? Is 50 enough? You know, there's wiggle. But these answers are going to end up being basically the same. They'll be maybe a decimal or two off. But if you had an online homework for that, yeah, I'm sure the grader messed up. Yeah, statistics gets messed up all the time. You saw even as I got to look this stuff up, and I have to see like exactly which one it is. Because there's subtle differences that force you to either use like pooled standard variances or like, you know, these types. Okay. All right. Well, okay, we'll follow this thing. Really, I should have used a Z distribution. All that's going to change is this number here. Instead of it being 1.984, it would be 1.96. Okay. So technically this would be 1.96. So we're going to use the Z value here is what we're going to do. Yeah, statistics is important, Falconer, for science classes, especially like, yeah, biology or any sort, like if you're taking samples of soils and stuff and whatnot, like, yeah, this is all very important stuff to know. But, you know, do you have to know it exactly? Like, I don't know, you know, it's good enough, right? I think in any case here, like even if I were to, let's switch that to 1.96, I guess, it's not really going to change the value that much. So we have this. Yeah, again, dude, it's 0.588. It's going to be the same number. It's the same number. Like 1.984 and 1.960 is basically the same thing. Yeah, 0.732. Cool. All right. So, this is our confidence interval here, right? It's 0.588, comma 0.732. So what's your conclusion going to be if that's your confidence interval? This is a good question, Falconer. Failed to reject. I would say you do reject X naught, because what was H naught saying? Let's remember what was H naught. Yeah, right. Yeah, you're good. H naught is that it is equal to 0. Is 0 in that confidence interval? Good. Yes. Exactly. So this confidence interval is saying, I think the difference between these two is between 0.588 and 0.732, which the 0 is not there. Yeah, no, it's okay. Dude, my brain messed up a lot of things with Cosmic's question. You're totally cool, dude. Yeah. So yeah, conclusion. Cosmic's like lol. So yeah, this is yeah, reject H naught and then say there is, you know, sufficient to determine that there is a difference. You're very welcome. Okay, and then here's kind of a little tip for statistics and whatnot. Sorry for the pain and suffering. It's part of my daily life. I know, engineering degrees, dog. Falconer, whenever they ask you to like state the conclusion, just literally rewrite this shit word for word. It's the best way to make sure you don't get any points counted off. Because, like, statistics has all these weird things where, like, you can't technically prove an alternative hypothesis, right? You can just reject the null, and then you can't, it's like, reject, fail to, so, like, you're only really allowed to say things about the null hypothesis, which is either I reject it or I fail to reject it. Don't say anything about the alternative hypothesis. Don't say you accept the alternative hypothesis or anything. Yeah, and see, this is also the key thing here. I would say, because I don't. It depends how nitpicky your teacher is. I don't think you can say you're 95% certain that there is a difference. I think you can say, we reject the null hypothesis at the 95% confidence level and determine that there. Yeah, sure. That's probably right, but. Statistics is so like, it's like walking on eggshells. Okay, good. All right, if that's how your teacher wants it, it's fine. Some statistics teachers get really mad and they're like, no, it doesn't mean that there is. It just means that there's not the possibility that there's not or something. And I'm just like, okay. Yes, in layman's terms, you're 95% certain that there's a difference. Okay, that makes sense then. Yeah, if they were like a hardcore statistics professor, they would probably be more... yeah, I'm trying to think of the word for this. More anal. Yeah, they would be more like weird, more nitpicky about it. Yeah. You're the guinea pig. Okay. Unfortunate. Okay. But yeah, hopefully that helps you out. If you have a TI-84 and you're allowed to use it to like double check your work here, how you would do this is you would go to stat here. You would go to tests. You would go to two sample z-test. So 2 sample z-test right here, right? And then you would just put in all the numbers. So, oh, but you need a confidence interval. Sorry. Let me see. One sec. Tests. Here we go. 2 sample z interval. This is what you want. And you can literally put in all the numbers here. So what was this? This was, well, the problem is like they gave you variances, so you have to find the standard deviations. So this was 0.1897, and then if we had the square root of 0.048, that's equal to 0.2191. 0.2191. So let me just see what that comes up as. I just want to see if we get the same answer. We probably should. 2 sample Z interval. There we go. So the first standard deviation is 0.1897. Second one is 0.2191. X bar 1 was 3.61. That N bar was 45, right? X bar 2 was 2.95. And then N2 was 90. And then confidence level 95%. Calculate. Cool. Yeah, you see how that's basically the same answer there? Yeah, we have to use calculators and note sheets. Yeah, but if you have a TI-84, literally, you see we get the same answer here. The confidence interval is between 0.588 and 0.732. So you can always double check that you're using the right equation. Or that, really, you're just double checking that you did, like, this math correctly. Which, you know, as we've seen earlier, I sometimes screw up on basic math. Okay, Teacup, I will do your question. Last but not least. What are we doing? Yeah, TI-84. Yeah, it's the best. It has all, dude, it has all the statistics in it. It'll do all the stats for you. It's the best. Love it. All right, Teacup, what's up? Where you at?
Hello.
Hello. Okay, nice. All right, let's do it. Sometimes I have difficulty using it. Yeah, just get, practice with it. Like, when you do one of these questions, do what I did. Like, try to redo the question with your calculator, see if you get the same answer, and that'll help you get familiar with it. Okay, cool. All right. We had this. We did this first part here. So second part was show that if r is less than the square root of 2, then s of x is an increasing function. Conclude that the cone has a minimal surface area in this case. Okay, cool. So here's our function, right? Sx is equal to pi r plus x times the square root of 1 plus r minus x squared, right? Right, Teacup?
Yes.
Okay. How do I show that something is increasing or decreasing?
Increasing or decreasing?
Uh-huh.
Is it positive or negative?
If what's positive or what's negative? What's the whole thing we're learning? The slope, good. And what's the slope in a function? What's this whole thing we're learning in calculus? The what? Starts with a D. Starts with a D.
Discontinuity. Wait, no. Wait a minute.
What are we doing in calculus, dog? Derivative. Yes. If the derivative is positive, then it's an increasing function. Okay. All right.
Like a 5 actual education stream question. We're going to like one question a stream.
Yeah. Well, because they're all complicated. So we want to see what ds dx is. Cool.
Yes.
So we gotta take the derivative of this massive fucking bitch. All right. How do we do this?
Okay, dear God. Okay, so...
Dear God. Oh, God. It hurts so much.
Okay, so we gotta do pi to the 0 all...
No. You only take derivatives when things have x's in them, right? I can expand this out if I want to. Actually, let's just pull the pi out.
Would it be derivative of all plus x?
This is pi r plus pi x. Okay. And then it's times all this mumbo jumbo, right?
Mm-hmm.
Actually, you know what? No. Let's just pull the pi out. Let's pull the pi out. Just make our life like kind of easier.
Okay, so we just have all plus x.
So this is d dx of r plus x, and then this is going to be 1 plus r minus x squared all to the, I'm going to say the 1/2. It's just easier when I write square roots as powers,
So
right?
will we do derivative of all x, l, all minus x, or just be x?
So this is going to be a product rule where this whole thing I'm going to call A, and this whole thing I'm going to call B. Yeah.
Minus b is equal to
No. So let's remember. What's the derivative of these two things together? What's that equal to?
derivative of a times b.
Yeah, what's that? What is that?
What was that? ab prime or something?
Yeah, good. It's a prime b plus
Time
plus
prime a.
ab prime, or b prime a is what we say.
Oh.
Yeah, good things to remember. Okay, so let's do this. Let's figure out what a prime is first. What would a prime be equal to, if this is a?
It would be derivative of all plus x, which would be
Yeah,
all.
Yeah, I
to
get them
the
confused too, Cosmic.
zero.
So what would it be?
Would that be like 1?
Yeah, it would be 1. Yeah, exactly. So r is a constant, so the derivative of r is 0. X is x to the 1, so that becomes 1 times x to the 0, which is just 1. Right, good. So this is just 1. Cool.
And then now we need b prime, and b prime is.
Yeah, what's b prime? Yeah, B
we
prime
have
kinda
L
sucks.
to the 0.
No, that's a 1.
that
That's a
an
1.
one or
That's a
an-
1. It's a
oh,
1. It's a 1.
one. Okay, so that's just 0.
So this is actually even harder though, because this is going to be a chain rule as well.
You gotta times the all minus x by the.
Yeah. Okay. So here we're gonna go over it. I'm making a TikTok video on this. Like I'm
First,
almost.
you gotta do everything times 1/2, and then.
Good. Thank you. Yes. Exactly. Yeah. I'm gonna pretend that this is all like something, right? So this is gonna be 1/2 times this thing to the what? This is 1, right? The derivative of this is 1/2 times this to the what power?
Let's see. I don't want to say 1. I don't want to say 2.
What do you do to this power? Cosmic knows it.
We
What do you do?
drop.
You drop it. Drop it by how much?
Yeah, drop 1.
So what's 1/2 minus 1?
Clearly, it's negative 1.
Good, very good. So this is negative 1/2. Okay, cool. Take away the block. Okay. Now, right? I need to do the derivative though, right? Of this whole thing, right?
So first, we gotta times all minus x by.
Yeah, so this could be I could do another chain rule here, but this is luckily a low power, which is okay. So yeah, this is 1 plus r squared minus 2rx plus x squared. So this is okay. That's what this whole thing is here. Okay. So then what's that derivative? Yeah, what's that derivative?
0 plus all minus.
No. R is not an x thing. R does not depend on x, right?
Oh,
So that's gonna go away. That goes away. That goes away. Again, you're only taking the derivative with respect to x.
minus 2 all x to the 0.
Good. So it's just minus 2r.
And then we have plus x.
No. Not plus
What?
x. What's the derivative of x squared?
It would be x to the 1.
2x to the 1.
Oh,
Remember
yeah, I forgot we had to.
You gotta drop the
multiply.
2. Gotta drop the 2. Okay.
Yeah, my
Cool.
bad. I forgot how math works.
I forgot how math works too, dude.
Listen, it's like 9:05. Okay.
I know
I've
it's
been
late.
waiting for 3 hours
I know.
for
I
this
appreciate you waiting. It's good. We had a lot of like kind of first time questions I wanted to go through today. All right. Cool. All right. So this is B prime. It's a
question.
huge
This is
slut.
totally related. Do you play Assassin's Creed?
No. I know of it. I just haven't played it.
They're remaking the pirate one.
Oh, that's cool. I remember when the OG came out. Dude, I've been around for too long. I remember when the OG Assassins came out.
Oh, yeah, Assassin's Creed is good. Personally, I think I'm gonna put Black Flag on top, then Unity, then I'll see.
Okay. Let me get rid of the 1/2 here. Okay,
Oh,
so this is what I like to do just to keep things straight because, like, dude, I would get so confused trying to do this in my head. is I write out what A prime is, what A is, what B prime is, what B is, and then I just like I plug this shit into this equation, and we just see what
so
happens.
We gotta do all plus x times.
No. So it's A prime. A prime is just 1.
So 1 times 1 plus all minus x to
Yeah, so it's all this. Yeah, luckily I have copy paste, right? Okay, cool.
and then
Plus.
we have plus all plus x
Yeah.
times 1/2 1 plus
Times this
all
fucking
minus-
garbage. Yeah, this sucks.
I don't like B.
I don't know, dude. This sucks. Okay. All right. I think that's right. Yeah. All right. B prime. Yeah. Okay. And then all this is technically times pi.
I don't want this by hand. Can we just like put this in TI-84?
No, we don't. No, this is actually okay. Do you see how I have? Okay. Well, actually, I don't have this. So this goes on the bottom, is what happens, right?
No. Okay, now I gotta cancel those 2 out, and then.
No, it's okay. No. This is gonna go on the bottom. This is to the 1/2. And then this is on the top. This is kind of messy, dude.
Can we not put? Can we just put this in the calculator?
No.
They
Okay.
invented them for a reason.
Okay, I want common denominators, right? I'm going to ignore the pi. I don't care about the pi. The pi is just a multiple. What I'm really trying to show is that this is equal to 0 at some point. Because when the derivative is equal to 0, that means it's either a max or a min.
Let's just plug everything into 0.
No. Because we need to show that when r equals something, this whole thing goes to 0.
Okay, so we have all minus x squared 1/2, and then we also have all plus x squared.
Yeah. So we have this on the top and this on the bottom. So what I'm going to do is I'm going to multiply this thing by the bottom and the top, right? And so if I multiply by 1/2 by 1/2, this is going to go away. And so then eventually I have like all of this all over the same, sorry. I have all this over the same, same denominator.
Cool,
Which
I
is
get what you're
nice.
trying to say, but your words aren't corresponding with the actions on the whiteboard.
Yeah, I know. I'm being kind of lazy here. Okay. This is what we get to.
What is that?
It's okay. I did a
We're not
couple
with
short.
the 1/2.
I did a couple shortcuts. Okay, so this obviously screws up if r is equal to x, right? Because no, it's actually okay.
I thought we got rid of that 1/2.
No, so no, we left this here. So what happened was I had like this thing with a 1/2, and I multiplied the top and the bottom by the same thing to the 1/2. So this became to the 1, and then it was able to combine with this one. That's what happened. I can show it again. It's okay. I'll show it. It's alright. All right. I skipped a lot of steps there. I understand.
Please don't go. I just want this done. I'm tired. I need to go to bed.
I'm tired too, dude.
I got a test tomorrow.
I still gotta go get dinner with like some chick, dude. Like what?
I have a presentation tomorrow. What
Oh,
time
okay.
are you having dinner? It's like 9 o'clock.
No, it's 6 o'clock for me. Okay. This was my expression, right? Do you remember this?
Mhm.
Oh, and I think there was a 1/2 somewhere. Ugh, fuck.
Methamphetamine.
Methamphetamine.
It's good for you.
Yeah, there was a 1/2 here as well. From this thing. Yes, okay. So, teacup. I want to combine this with this, okay? If I have A plus B over A, do you see how these are the same things? Just one's on the top, one's on the bottom? I'm going to multiply this by A over A to turn this thing into A squared over A. And now I can combine these to be A squared plus B all over A. Do you see that?
Yeah.
So what I did here, oh please let me grab this, is I multiplied the top and bottom by the same thing. Yeah. Yeah, I skipped a lot of steps. And honestly, I hate when professors do that, but like when I'm at like the 2-hour mark of teaching, I'm just fucking tired. So when these things combine, right, this is the same thing as a square root times a square root, which is just going to get rid of the square root. Does that make sense, Teacup? If I have the square root of a times the square root of a, what do I get? You just get a, right?
Yeah.
Yeah.
Like, it would cancel
So
out.
that's why this just gets rid of this thing, okay? And then this, right, is in the denominator. Now they have the same denominators, so I can just add them together. You sent a practice question? Okay, cool. All right, yeah, I'll do it, dude. You guys are lucky today. You guys are lucky to be nice today. A mode. A vector. Okay, yeah. I want to see what your teacher's doing. Okay, so now we get to this. But now I want to know when this is equal to 0. Right? And the answer is supposed to be when r is less than square root of 2. So let's see if that makes sense, why r is less than the square root of 2. I don't see it up front here, man. What? R is less than the square root of 2? Oh, it's positive. Oh, okay. So, well, okay, so they're saying that at square root of 2, this is equal to 0. I think. Does that make sense? I don't know that it does. This will always be positive. This will always be positive because you're squaring something. So I want to know when this is more negative than this, okay? So I really want to know is when does 1/2 r plus x times negative 2r plus 2x equal equal the negative of this, basically. Equal negative 1 plus r minus x squared. Okay. Oh, okay. I think this just becomes a quadratic, which is nice. So this is, so the 1/2 will kill these things off, which is nice. Goodbye. Okay. Oh, okay, look. R plus x, x minus r. And then this is equal to negative 1. And then this is plus r minus x squared. So this is the same thing as negative r minus x. So this becomes negative r squared plus x squared. It's a difference of squares. It's equal to negative 1. And then this is plus r squared minus 2rx plus x squared. X squared cancel. Good. Oh, man, I want this last x to go away, dude. 2r squared minus 2rx minus 1 is equal to 0. Oh, it's so close. Dude, that single fucking x is gonna mess with me, dog. It's so close. R squared minus rx minus 1/2 is equal to 0. And I think the solution for that one is, let's just look it up real quick. And then what I have? Do I have x minus x minus 0.5? Yeah. That happens at I don't think that's square root of 2 over 2. What is the square? The square root of 2 is 1.41. All right. Yeah. Damn. Okay. Doesn't happen there. It's close. It's so close. You gotta go? Oh, okay. All right,
I
Amog,
attack.
yeah. I was like, Amog, let me help you on Friday with that if you have questions with it. I think you know how to do that stuff. Stuff's easy, dude. Dude, where's this last question I had? Sorry. Okay. Let me just. All right, this is it. Let's just make sure our derivative is fine. Derivative with respect to r of, and then it's pi times r plus x times the square root of 1 minus r minus x squared. Let's see. R minus x squared, yes. Yeah. Oh, it's just so ugly. Oh yeah, but look, cool. Yeah, there's our thing. Yeah, I think this is what I had, right? This is negative r squared minus x squared, good, is equal to r squared minus 2rx plus x squared minus 1. Oh, I'm missing an r plus x somewhere. Okay. Where am I missing it? I think it's so hard sometimes. All right. What's wrong? What's wrong here? What's wrong here, dude? This is okay.
Oh my god.
Yeah, no. Yeah, I'm just trying to see, dude. I'm close. I'm so close. I'm so close. I hate being like so close. Okay, first of all, where'd my 1/2 go? I just got rid of the 1/2? Excuse me?
I'm cold. I'm looking at common area. Why did it take you so long to understand the Five Guys meme?
I know, that was bad because I forgot Roman numerals, dude.
I forgot Roman numerals exist. It's kind of funny though.
I did.
I'm so
Why do they put pi prime here? Sorry, what's pi prime? Sorry, what? One sec. I want to see if this is just okay. Let's get rid of this. I'm just do it the Wolfram way. There's something wrong with my algebra, but I can't figure it out. Oh, okay. Ooh, there we go. Yeah, no. I have this. Okay, no, I have this answer. This. I have the right answer here. Okay, this is correct.
Did it?
We did it. Yeah. Okay.
With the help of a calculator.
No. I did this. I got this answer. This is exactly what I have right here. This is what I have. The r squared minus rx minus 1/2 is equal to 0. That's what this is.
We did it.
This is r squared minus rx minus 1/2 is equal to 0. Cool. So when does that equal 0 though? R squared minus rx minus 1/2. R squared. Well, here. Let me copy. I need this. Okay. I need to set this equal to 0. So r cannot equal 0. And they say, okay, when x is equal to 2r squared minus 1 over 2r. Right?
Yes.
How do I solve that for r? Let's solve that for r.
Reactions. just toggle now. There's not like a limit on them.
For what?
Super reactions.
Oh, you can use them infinitely now?
Yeah. If you have nitro.
Oh, cool. Yeah, I do. Dude, I want to get this. Solve for R. R is equal to... Here we go. R is 1/2 x minus x squared plus 2, or this. Where does that tell me it's the square root of 2, though, dude? Is x something special in this question?
I think I might go to bed.
I know.
See you next year.
One sec.
I gotta
Conclude
do it.
if R is something. Oh, x equals 0.
No.
If x equals 0, then R is positive. Oh, I don't know.
No, so it's the maximum.
Oh, my brain is tired, dude. I've been streaming for 2 hours and 20 minutes.
It is 9:30.
All right, I'll give you credit for it. Like, oh man, this one's racked my brain.
Alright,
Sensation, what
no
time is it for you, dog? Dude, it's like 5 in the morning for you.
It's 2 a.m.
Oh, that's pretty standard time. Okay, cool.
I do need to stay awake for quite a lot longer though.
Yeah.
Alright, Gold. I guess I'll ask you about question C next time.
Yes.
That's dope.
Okay, let's end the stream. All right.
Have a good one.
Thank you everyone for coming to this special extended edition of Office Hours. 9:30 p.m. for Cosmic. Yeah, you're on the East Coast, Cosmic. Yeah. Yeah, try doing some of those Cosmic. They're not too bad. The other questions you have, and let me help you on Friday with them. Yes, thanks everyone for coming by. Tomorrow we got the Golden Hour stream. That's gonna be at is that the same? No, it's an hour earlier. So that one's at 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. Feel free to come by, ask questions about anything, politics, religion. I don't know, dating advice. I'll try and help you guys out. I don't know. I got a date with a girl after this, so I'm doing something right. Yeah, that'll be on Thursday.
You don't need it.
Yeah, dude, I do need luck. Dude, you need all the luck in LA, dude. Actually, there's a 50-50 chance she just doesn't even show up, honestly.
Well, it could be worse with the 50-50 chances.
It's okay. I'm gonna eat pizza regardless. Like, I don't care. It's a really nice pizza spot. It's like a pizza wine bar place. It's super good. So I'm just happy to eat pizza.
It's just like 50-50 chance that she might not show up. Oh well, it could be 50-50 chance she's a man. So
yeah, it could be no, she's not a man. No, because I met her. I've met her once before. Sam says where? Bodega. Bodega's great date spot. I heard pizza wine bar. Yeah, it's Bodega. Bodega is one of my favorites. Yeah. All right. The Office Hours stream where you can get more homework help. That's on Friday. And that one's gonna be an hour. I think that's actually at the same time as this one. Wait, fuck. Yeah, it is. That's at the same time as this one. So that's gonna be the same. 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. So, yeah, please come by that one if you want to get some more homework help. I would do recess with you guys, but I gotta run. We went a little bit over time today, but I'm glad. I'm happy. We worked with a lot of students I haven't worked with before, and I'm happy to help you guys out. Cool. All right, little closing credits. Thanks for our top subscribers. Wow, Sensation Black, dude, you're up there. You're one of our top subscribers.
Again.
Yeah, look at that. Look, yeah, you have a 4 subscription streak. I don't know why it doesn't list you, Sam, yet. Maybe it's because you haven't subscribed in the last 30 days. I don't know. It's whatever. It's something on the bot, whatever. And then our Discord server boosters. Love you guys. It resets tomorrow. That's why. That'll be cool. Yeah, good to see you, Cosmic. Yeah. Come by on Friday. Come by Thursday if you just want to ask some random questions. I'd love to, like, if you want to pick my brain about, like, college and stuff. Yeah, down for it. Okay. Initial wants to say something. What's up, Initial? I'll give you like 2 minutes. I gotta go. I really gotta run. What's up?
Hi, I just want to say hi.
Hello. Are you coming to Golden Hour tomorrow? I missed you last week.
Is that everything? He just bailed.
Okay, he just bailed. All right, whatever. Okay. Have a wonderful rest of your Wednesday. I will see you guys tomorrow. Cool. Peace out, guys.